Runs right through the center of the site.
It's pretty good drone shot. That really kind of nails it right there.
Yeah.
I'll let you control the lobby if I don't accidentally close something.
Nope,
There's the
my
note taker.
I'm gonna send the note taker home.
Deny them.
Denied. We're recording, so we don't need the AI to help us. Hello, hello.
Hi, can everybody hear me? Just double check in audio since it's for us
Yes.
an external Teams. Awesome, great.
Yep, can hear you, Megan. Thanks.
Can hear you. It's coming in. Hello.
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 We'll give folks a little more time here to pop in. I don't really know how many people we're expecting today, but I think it's a pretty good sized group. We'll see. Coming in.
Hello.
Hello.
Hi there.
There's Luke. All right. Well, looks like we got 17 of us here, so that's pretty good. I wasn't sure who all was going to be here. Um, so thank you guys all for showing up, and I hope we can run through some new developments with the project and sort of give some updates and go through design and so yeah, so welcome. I'm gonna, I guess, just sort of, brief agenda, check in. So we're gonna, run through. Intros are going to kind of happen as people are presenting information because we don't have enough time, I don't think, for everyone to introduce themselves individually. So we'll do that sort of as it occurs as we go. And then, yeah, we'll kind of run through the project timeline and kind of see how it goes from there. So yeah, so there's a lot of people involved, a lot of partners involved in this project, and that's one of the key points that we keep trying to, you know, make that this is a huge partnership effort, and you know, this project could not be happening without the massive partnerships that we've been able to forge. And so here's just a few of the players here, and there's a ton of them. So yeah. I guess I'll kick it over to Jason Elkins with Parks to kind of talk about sort of what's happened to date, where we're at.
All right, mute Jason.
Thank you. Has to happen once during every meeting, it feels like. But sorry, so Jason Elkins, park manager at Cape Lookout State Park, and which also we manage Sitka Sedge State Natural Area. And not going to read through this, but quick overview. So OPRD acquired the property back in 2014. And in the next few years, we did resource assessments, biological, cultural, recreational, and scenic, and worked through our master planning process, and also initiated hydrology studies. And we opened the park to the public in 2018. And after that, we continued with groundwater investigation or effects investigation and the hydrology studies, and formed this technical team, an assessment of the conceptual alternatives for the issue with the tide gate on the existing dike. And that began in 2019. In 2020, we presented the findings to Tillamook County commissioners and the public, and then later on made the decision. OPRD made the decision to select the setback dike alternative for further analysis. And 2020 through 22, TEP took the lead on moving forward with the designs, working with ESA beginning in summer of 2022. And from there, refined the alternatives analysis and met with technical team throughout that process as well. And ESA did a presentation of the preliminary work to the public as well as the tech team. And then we eventually landed on the northernmost setback dike location. And we got to 30% design in spring of 2024, and we are currently in, Hunter and ESA just finished up 60% design. And we'll be having a town hall on that October 3rd as well, on Friday. And with that, get to Hunter, I believe.
Yeah. Thanks, Jason.
Yep.
My name's Hunter White. I think most of you know I'm the senior civil and water resources engineer with ESA and project manager for ESA, pushing this design towards completion and permitting, working towards construction. So as Jason kind of recapped the long history and timeline of this project, this slide here is really the design phase that we're in now. Back in fall of 2023, we, as Jason said, presented the alternatives analysis, and shortly thereafter launched into our actual design process, taking that towards construction drawing format, and really a lot of the work and investigations that have fed into the permit applications that we're working on now. Kind of skipping through that, as Jason said, here we are now. We've just completed our 60% design plans and have sent those out, I think, to all attending here. With the 60% design set, we've also been, working hard on the permit applications. We completed a wetland delineation and functional assessments of the site, cultural resources investigation, and geotechnical investigations. We've also been doing a lot of coordination with other sub-consultants on our team, geotechnical engineers Shannon and Wilson, as well as David Evans and Associates, who are designing the bridges, structural engineering, and roadway engineering. So as we move ahead into the next couple of months, we're finalizing and submitting all of our permit applications, including the joint permit application for state and federal permitting and the Tillamook County land use applications. We've also had a number of pre-app meetings that I know quite a few of you have been involved in as well. We're working towards final designs in the spring 2026, and then pending all permits and grant funds that are funding the construction of this project, we're working towards beginning construction in the summer of 2026.
Yeah.
I think I'm going to pause there and make room for just an update on some of the funding aspects.
So I'll jump in and just say, so we have a lot of really exciting pending funding for this project, as well as some confirmed funding. And so we can get into the sort of the details of that, but there's a lot of pending grant funding to make this project as a whole happen, including road crossings and fish passage barrier removals and the whole shebang. So one of the big elements of this is getting some funding recently, and I'll let Claire jump in and tell you about what has just sort of become reality for funding.
Thanks, Krister.
Yeah.
So my name is Claire Figner. If I haven't met you yet, I work at DLCD in the Oregon Coastal Management Program. And we get a lot of our funding through NOAA for the work we do. And there is a funding source that was earmarked for coastal management programs that funds sort of large scale restoration projects. And if you know DLCD, we don't own or manage land, so we were able to open up that opportunity to our eligible partners to apply through us, and we've helped facilitate that process. And so, as Krister alluded to, we are very excited to say that even though it was a bumpy road to get here, we just recently were awarded and accepted about $6 million towards this project. So implementation towards this project. And as Krister said, it's not the entire project, but obviously a pretty significant portion. So that is really exciting. And we are just doing additional steps of getting those funds sub-awarded to TEP directly to work with their consultants to move forward the implementation. It's a 3-year funding program, so they have a 3-year work plan to do some of the implementation. And I'll be involved to help with technical assistance as we can. I think that's probably a good enough update for now, I think,
Yeah,
unless
thanks,
anybody
Claire.
has questions.
Yeah, great news. Thank you.
Yeah. So I guess I'll just touch on a couple of the other pending sort of funding opportunities that are out there right now. Gonna run through this because we gotta get into the 60% design review here, but we do have opportunities that are through partnerships with the county and through Salmon Superhighway and Trout Unlimited, Wild Salmon Center, NIFWIF. There's multiple things in the pipeline right now that are going to make the funding for this entire package project happen if everything kind of falls into place. And so that's where we're at right now, is sort of making things line up and see how we can get things to fall into place and make this all happen. So I'll leave it there and let you keep going, Hunter.
Great, thank you. So we'll spend the rest of the time here going through just a little bit of context for those that need it. It looks like most folks here are familiar with the project, but we'll just give a really brief overview and then start diving into excerpts really from our 60% plans and try to leave a good amount of time at the end for questions and discussion. So for quick orientation, on the location of the project, we're here in southern Tillamook County on Oregon's north coast. Zooming in here, we're just north of Pacific City, and the small town of Tierra del Mar is at the south end of the project area. Here on the left, you can see a little bit more zoomed in of the park itself, park boundary in red, Belts Dike here separating Sand Lake and the open estuary from Belts Marsh south of the dike, and then again Tierra del Mar to the south. We do have three streams that flow into this project area. Reneke Creek is the largest one, and coming in northernmost creek, Belts Creek kind of right in the center, and then No Name Creek, or the area that we've referred to as the East Marsh at the south end of the project area on the east side of Sand Lake Road. The purpose of the project, and again, I'll just kind of breeze through this. Most of you are familiar already. The existing tide gate out there structure is failing. The tide gate itself is completely missing at this point, and kind of seen down here in the bottom right, the structure has a lot of erosion around it, and it's kind of a matter of time before that embankment would fail on its own. So really wanting to have a good plan and not have just an accidental breach that we're not prepared for. We also want to provide fish passage into the three creeks that I just mentioned, and I'll kind of keep going from there. Just briefly, we'll show for those who haven't been out there at some of these moments when we have a lot of water rushing through the box culvert structure, that we really have very fast water moving through. We have these big eddies that set up both inside and outside of the tide gate structure, and that swirling motion is really causing a lot of erosion around the structure and eating away at that embankment. Even a cool little whirlpool feature that sets up here on the outside when water's draining in. We went through several steps of alternatives analyses, looking at replacing the tide gate structure with a new modern tide gate system, a full dike breach, which is essentially what we ended up with, spanning with a pedestrian bridge, and then the setback dike concept, which was selected by Oregon State Parks as the preferred alternative, coupled with a dike breach, but building a setback dike at the south end of the marsh to minimize high tides from reaching Tierra del Mar, and providing drainage for stormwater. As Krister mentioned, we're also working really closely with Tillamook County Public Works, and each of these three streams crosses Sand Lake Road, and all three of them are fish passage barriers. We're looking at Reneke Creek here, which, as I said, is the largest creek and also the county's highest priority for replacement. This is a location where the road overtops frequently during the winter. It had a culvert that has filled in with gravels, and so right now the stream is completely flowing through the roadside ditch, making a hard turn to get through the undersized culvert. And Reneke Creek culvert replacement and associated roadway improvements are part of the Sitka Sedge project now. Belts Creek and No Name Creek culvert replacements, we are designing those to a 30% level, but there's not currently funding to take those any further, and are not being advanced as part of the 60% and additional stages of design at this point. Oops. So now here, kind of looking at our preferred alternative concept map. North is down in this image, so we're over Sand Lake looking south into the project area. Starting at the bottom end, as water will enter the marsh through a new breach through the Belts Dike. Of course, there's an amazing trail network out there on the dune, providing access out to the beach, and again, just a really nice trail network that, while breaching the dike, we also needed to maintain recreational access to this trail system. So we are spanning this dike breach with a pedestrian bridge that I'll get into in more detail. Again, showing the setback dike at the south end of the marsh, which will be providing continued flood protection for Tierra del Mar, and the low point at Sand Lake Road at the East Marsh crossing. And then again, Reneke Creek coming in here from the west. We're doing a bit of a realignment, restoration of that floodplain area, which again, I'll talk about in more detail. This is a nice shot that Krister annotated, just showing now looking north again into out to Sand Lake, Belts Dyke here highlighted in the red box that was built in the 30s, and the location approximately of the dike breach and 140-foot span pedestrian bridge. This is roughly where the setback dike will cross the marsh as well. And you can't see it too well in here, but the existing beaver dam is just south of that setback dike location, which backwaters and will be essentially maintained as freshwater marsh and a beaver dam, beaver habitat complex at the south end of the marsh. A couple photos just looking out into Sand Lake from the dike, and then looking back into Belts Marsh, the area that will be reconnected through the dike breaching. Now we really switch into glimpses of our 60% design, and with all of the work and effort and alternatives that we've investigated, it really boils down to, really a few key project elements here. Again, the dike breach with the pedestrian bridge at the north end, the setback dike at the south end of the project, and I'll get into some updates on the alignment and kind of design logistics for that. As you see here in the blue, new sinuous tidal channel network, we're proposing to significantly increase the tidal channel density within the area. While this is kind of our one shot at significant restoration. So going along with filling some of the linear drainage ditches, which Jasper was pointing out in one of the overview shots at the start of the slide. So filling some of this linear drainage ditch network in the center of the site, as well as the drainage ditch that follows the backside of the setback dike, and then establishing or reestablishing sinuous tidal channel network within a good portion of the marsh. Some of the area closer within the center, it's really functioning as open water now. And while there are a couple of linear features in there, just the prospect of trying to get in there to fill them is pretty daunting. It would take a lot of fill. And again, especially with higher water levels frequently inundating the marsh, a lot of that central area will just function as open water habitat. And then to the east here, which is now, pretty significant element of the project, is the Renicky Creek culvert replacement. We're raising the road about 2 feet to get adequate freeboard clearance beneath the new bridge, which involves about 650 feet of raising the road. So it's just only 2 feet vertically at the center, but in order to tie that in with the road approaches heading to the north and south, it ends up being about 650 feet of road raising and some realignment of Renicky Creek across its historical floodplain, which we'll talk about more. So this is really just kind of showing some of the rationale and location for the dike breach. Really looking at historical channel connections and and even these historical channels that are still there, playing on kind of the primary, most dominant channel form that we wanted to connect into with our breach channel. And so again, this area highlighted here is what we'll zoom in on now. Really zoomed in at just the breach, showing the grading here. As I mentioned, we're wanting to fill these drainage ditches, particularly on either side of the breach, really to redirect water out to the center of the marsh and then to kind of line up and flow through our new bridge opening more directly. One of the things we were seeing in the hydraulic modeling without filling these ditches is that water coming in laterally and then making that hard bend out beneath the bridge. We were seeing some hot spots of erosion potential around the abutments. And so that's part of the rationale there. And then picking up some of these flows from the east, kind of the northeast corner of the marsh and the area where the existing tide gate structure is, and pulling those back in to line up with our new bridge opening. We'll also be picking up flows again from this linear ditch line that also connects out into other areas of the open water. This is a plan and profile view, zooming in a little bit more on the breach itself and 140-foot span pedestrian bridge. David Evans has been working on the abutment designs and then also coordinating with bridge manufacturers, anticipating this will be a prefabricated pedestrian bridge, likely a contact type of structure. And we're developing the breach grading here. I've kind of mentioned this in a couple other presentations of, how deep to make it. We are kind of over deepening it right now compared to the channels that we're connecting into on either side, but anticipating that moving all of this water in and out of this opening on a daily basis, this is roughly the kind of equilibrium channel size that we are designing towards. I won't get into, unless folks do have questions, of, the modeling that we've done around selecting the size of this opening and bridge. At one point we were looking at a 200-foot span, a 100-foot span. We're kind of landing somewhere in the middle, 140-foot span. And that is really, it's, once you go up above 140-foot span, we get into a different size class of bridge, different type of structure really, and becomes significantly more expensive, like almost doubling or tripling the cost as we were to go to even just 20 feet more in span. So we also have analyzed the erosion potential, and even with the 100-foot span, the velocities and shear stresses through this opening are quite low. With the 140-foot span, we really don't need riprap per se or significant armoring, but the natural sand sediment that's in this system, of course, would be erodible. So what we're proposing here right now is some buried rock protection, and then covering that back up with soil, with the bridge being up pretty high and it's pretty narrow. So we do anticipate being able to get vegetation to grow at least on the upper banks, and really try to focus on just the sizing of the channel and hydraulics to predict how much erosion, and then really put in some rock that would be backup line of defense if we were to get erosion to protect these bridge abutments, but really anticipating that we would never see that rock again. This is a shot at the top, is from David Evans' plans. And just to note, so this does say 14-foot low chord elevation. We're actually planning for a 15-foot low chord, and I'm cleaning that up with DEA. But with the 15-foot elevation, that gives us about 3 feet of freeboard or clearance over the peak water levels that we experience now. We are having some discussions about, do we want to bump that up a little bit? But, with that, there are some kind of other complications of tying in the trail and widening out the embankment and so forth. So again, right now we're designing for about 3 feet of freeboard over peak water surface elevations. And the Continental Connector bridge model here from Contech is shown. This is a reasonable representation of what the bridge could look like out here at Sitka Sedge. Again, proposing it to be just a prefabricated system. And as we move towards final design and how we're going to bid this project, we'll need to make some decisions about, do we want to select the exact bridge that we want, or leave it up to a contractor to provide a bridge that meets these design criteria and performance criteria, with some flexibility in what the bridge, some of the details of the bridge. So we'll be refining that as we move ahead, but again, just a reasonable representation of what this bridge could look like. Moving on to the setback dike area. One of the main features that has always been described and considered in this project is the existing beaver dam. I guess it doesn't really come and go, but it does change its height and extent of inundation behind it, but it has persisted in all of the time that we've been working on the project. There's also a beaver lodge back here south in the channel network, and very active beaver activity in this marsh. And so both in order to provide enough stormwater capacity, storage capacity, to accept all of the flows off of Tierra del Mar in the East Marsh, drove our location of the setback dike. And then also, the concept of just giving the beavers the southern 10 acres of the marsh to kind of maintain as they're doing, has us locating the setback dike crossing. It's about 100 feet north of the beaver dam. You see here is not that straight line that has been represented in a couple of other diagrams in the past. We've refined this both through, where we want to tie into Sand Lake Road, the road raises up as you move to the north. And so the kind of the cutting straight across and tying in was actually pretty high. Also not great sight distances once you would tie into Sand Lake Road. So that was one reason for driving it further to the south. And then also, Sitka sedge has amazing vegetation for the most part, but there is a kind of a pocket of low quality vegetation, a lot of reed canary grass in this area. And so this is a zone where, we're not as concerned about what we're filling over. So a few reasons why we've modified the alignment here. Bringing this further to the south, as you could imagine, would reduce our storage capacity behind the dike some. And with that, we've also pushed the dike a little bit to the north as well. So we're essentially providing an equivalent amount of storage volume behind the setback dike. And we've also updated our hydraulic modeling to demonstrate that this configuration of the setback dike would perform the same as alternative one that we presented and have gotten buy-in from Tierra Del Mar Neighborhood Association. A couple other features here on the west side, we're tying into the forested dune as it rises up with a vehicular turnaround at the end. We are widening out the access road over the structure itself, the tide gate structure right here in the middle that will provide drainage of water and also allow tides in to some extent as well. You'll also see that we've shifted the channel location. And so rather than building the tide gate structure right on the existing channel, shifting it over will really make it a lot easier to build. And because we anticipate construction is going to take place over 2 years, we also need to maintain drainage through that through that duration. And so building the structure over here west, off of the existing channel will allow us to use the existing channel as stormwater and stream bypass all through construction. So that, that winter, when the project is half built, we still have full drainage capacity to move water away from Tierra Del Mar. We've also incorporated a couple of backup drainage culverts in the event that the tide gate structure were blocked for some reason, beaver activity. And we do have measures that we're implementing for beaver exclusion and preventing beavers from getting into this structure. But that being said, good backup system here of additional culverts that will be perched up a little bit higher, so they really won't flow on a typical basis. But if water level rises in the marsh up, raises a few feet up, then these backup culverts will activate, providing additional capacity during big floods, and then also, again, as a backup measure in the event that the main structure is blocked. These red X's you see are tree removals. And so, we have taken care to kind of minimize impacts to, specifically some really big trees. Here just at the southwest corner, there's, this massive multi-trunk, 72-inch spruce tree that we are avoiding, and we're protecting that tree. And there are, some unavoidable tree impacts associated with these tie-ins. All trees will be used in the project, adding wood structures to channels and to floodplain. And you'll see some of the wood structures, wood incorporation across the site as well as over in the Reneke Creek project area. So this is just switching to a quick view of the plan and profile. Here you can see we're, coming up to about 17 feet for an initial build height, and again, wanting freeboard over the maximum water surface elevations, as well as managing a lot of settlement during construction. With placing this much and this depth of fill over soft marsh soils, we're anticipating, significant amounts, even up to like 5 feet of settlement of that fill. Again, that's, one of the big reasons why we would want to build this over 2 years. So we build it to an initial height, let it settle and get a lot of that settlement out of the way, and then come in a second year and kind of clean it up and top off the top of the dike to its finished elevations, and then put an access road on top. So here you can also see the backup culverts that are, as I said, perched up a little bit higher. So they're not active all of the time, likely would be less attractive for beavers to block. And then we also really want to keep most of the water flushing in and out of our tide gate structure to keep it open and sediment free. But so providing these backup culverts perched up a little bit higher to focus most flows through the structure and then have them activate during higher water levels. This is zooming in on the tide gate structure itself. North is to the left to orient you, and you can see again the beaver dam, kind of the reconfigured channel connecting to and through the new tide gate structure. This red fencing essentially is beaver exclusion fencing that is being designed with 6-inch gap bar spacing in accordance with ODFW fish passage criteria for trout bearing but not salmon bearing streams, which No Name Creek has been classified. We're proposing a 12-foot wide box culvert with a single 8-foot tall by 10-foot wide side hinge tide gate, and that system being controlled by a muted tidal regulator control system that will allow tide water in to a specific water level setting, likely 8 feet. So we will get some tidal flushing on a daily basis, mostly downstream of the beaver dam, and we've created these extra little spurs of channel that will fill and drain daily as tidal channels. But then once that water level rises to 8 feet, the tide gate, the MTR will allow the tide gates to close and prevent higher tides from reaching the south end of the marsh. And then of course, during really peak tides, king tides up to 11 and even 12 feet, those water levels will not reach Tierra del Mar. And then, like I said, with that, the structure also will have, great capacity to drain out all of the storm water coming off of Tierra del Mar and the East Marsh drainage. Some of the other kind of enhancements across the site, as I mentioned, these next couple slides are showing the ditch filling and new tidal channel excavation. These tidal channels are being designed based on ESA's and formerly Philip Williams and Associates tidal channel design guidelines. So looking at marsh size, contributing marsh area, and tidal prism volume that will be moving and contributing to these channels. The channels are being sized through those methods. Again, like I said, you'll see wood structures incorporated throughout the project, some of them more as a structural element, kind of a bank stabilization element, and then also just wood additions for habitat complexity and habitat value. So again, the south end of the project, where we really are doing a more heavy-handed filling of the central ditch network, or ditch line rather, and then remeandering the main channel, and then also pulling off tidal channel networks from there. And here you can see, again, Reneke Creek coming in at the north end, and then Belts Creek, which, like I said, we are working on a preliminary design, and then ultimately in the future expect that this culvert is replaced. And both Reneke and Belts Creek are outside of the dike, so they will have full, unrestricted fish access, while No Name Creek is left behind the setback dike. These are just a couple examples of some of our wood structures, bank structure embedded in the bank and providing stabilization more so, a channel spanning structure configuration, and even just, floodplain logs that will be incorporated primarily in this Reneke Creek area. Just looking at time, and we'll get through the rest of this here pretty quickly and then open it up for some questions and discussion. As I mentioned, Reneke Creek currently hits Sand Lake Road. There's a culvert that used to be here that's completely buried in gravels. Reneke Creek flows down the roadside ditch and then takes a hard right turn to go out underneath the existing undersized culvert. What we're proposing here is filling a good portion of that existing channel and then redirecting it across this floodplain to the south with kind of a main channel, and shown here in dark blue, more sinuous and with wood, a lot of wood roughness and complexity. and then some side channels. And Renicky Creek carries a ton, tons of gravel deposits every year. And so we would anticipate that over time, even its current channel tends to fill in and pop out of bank. We would expect that these channels likely will also fill in, with gravel deposits over time and likely occupy, some of these side channel flow paths into the future, which I'll explain just a little bit more here after giving a quick glimpse of the revegetation plan. The cool thing about this area is that there is this remnant patch of forested wetland down here in this triangle at the bottom, in the lowland, focusing on a swamp, forested wetland plant community within the existing wetland boundary, and where we're realigning the channel through, and then restoring a lot of this area to upland forest as well. With a 49-foot span bridge down at that low point, and again, raising the road up a couple of feet. These are just shots from David Evans' roadway and bridge design. As I said, about 650 feet of road that will be affected by that. And just to get into a little bit of rationale on the Renicky Creek design. So, I guess starting with 1977, which is pretty similar to what we see today, we have this remnant patch of forested wetland and Renicky Creek's current alignment, but all the rest of this area has been cleared. Even back as early as in the 50s, all of this was forested. And as we and of course back in 1939 as well, completely forested. We've done a lot of analysis of what the geomorphology of this area is, and it is an alluvial fan where the creek comes out of the steep hillside, flattens out, drops a lot of sediment, and has a tendency to change its channel path over time. This is some of our just modeling of existing conditions and where Renicky Creek already pops out and accesses this floodplain. And so and then within this, remnant patch of forested wetland, there are channels in there still. And so our design would be tying back into some of these channels that are still present. Just a couple views of those. I think I see Chris has a question, and that's a good time. I mean, it kind of leads us into the discussion portion of the call. This is just flipping back to the overview to kind of spur some questions. So Chris, go ahead.
Yeah, mine was just an added comment that I don't think has ever been discussed before. So when we had that original 14-foot bridge that turned into the culvert became plugged, the road department was no longer able to clean the culvert because the fill on the estuary side had effectively blocked the flow of the water. So without cutting a channel through the estuary to allow Renicky Creek to flow like it was originally doing, the water was allowed to go down the ditch line to a much smaller culvert. So that culvert that is there now, that's plugged, a lot of the reason why we can't maintain it is simply because the estuary is silted in so much that maintenance was no longer an option. I just wanted to add that comment because I don't think we've ever truly talked about that.
Yeah, and so where Chris is talking about is essentially here where Renicky Creek hits Sand Lake Road, and there is a buried culvert there. There's also a man-made channel which has been brought up in particularly in the town halls of why aren't you restoring Renicky Creek's original channel alignment? And this is where Chris is talking about, of course, where the channel used to cross the road there. There are channel flow paths, and if you look back even earlier, 1939, you can see as water would make it out through that forested area, you see some channels that were likely carrying portions of Renicky Creek's flow out that way. But in the 50s, in association with the dike construction, there was a kind of a cutoff canal, if you will, constructed here that kind of goes around the end of the dike. It's perched up a little bit higher, but this channel has experienced a lot of gravel deposition over time and has really been a challenge to maintain. It was a man-made feature that we see pop up in the 50s, and again, that's been brought up a number of times as that's the original channel of Renicky Creek, but we have pretty good documentation that that was a man-made feature. So yeah, Chris, I don't know if you want to add anything more to that. I think even when there was a bridge, let's see, even when there was a bridge in this location, there still was a low point, down here where we're proposing to put the new bridge. And, this is the low point in the roadway. It's the low point in the landscape in general. And so even if a lot of the flows were being carried through that northern crossing, there certainly would have been times when during higher flows, this floodplain is activated. Water's always making it down to this low point. And even right now, if you go down there into this, forested triangle, you do see within these channels, even just groundwater seeping out. And, these channels, even without a good surface water connection, still do end up having flow even in the summer. So again, seeing these remnant channels that are still there and still carrying water and still do, when the when flood flows activate this area, still do carry stream flow. So that's really some of what we're playing on with our restoration design. Other questions and thoughts, ideas? Hey, York.
Hey, thank you. I had a question about Reneke Creek. I know you mentioned that there's going to be limited ditch filling. Did you look at the confluence of Reneke? I assume it was hitting one of those ditches, and will that confluence be manipulated or left the same? And then how does that relate to where that ultimate ditch comes in near the breach, and you showed that kind of U-shaped channel? Could you talk a little bit about the hydrology there, please?
Yeah, I'm not sure I have the perfect view up here, but Reneke, on the upstream side of the road, it's in the roadside ditch. It makes it down to the low point. It crosses that road, and then what we have seen, as I mentioned, Reneke carries a lot of gravels, and downstream of the road, Reneke has started to braid itself again and almost create this multi-threaded channel network downstream of the road, both through beaver activity. There's some beaver damming going on in there, as well as just sediment deposits that kind of push it around. And even just in the years that I've been watching this area, I've seen a lot of channel development in this Reneke Creek area, downstream of the road, that is. And there are a couple of well-defined flow paths. And so I'm sure it changes, year by year, and will change in the future. But there are two pretty well-defined flow paths out here that connect Reneke Creek out to the main channel network. So no, we're not proposing to do any work in there. In fact, it's all really well forested as well, really nice vegetation. And so it's kind of restoring itself. And again, in this area where if you zoom out and you look, like maybe not even the ditch line itself, but there is kind of a berm in between the channels. So it does look like an obvious kind of linear feature. But it's pretty wide, and it is also again, really functioning as open water at many water levels. And like I said, Reneke Creek has a couple of nicely developing channel connections into that larger channel and basin. That answer your questions, York, or do you have other thoughts?
Nope, that's good. Thank you.
Yeah, thank you. Flip back to the overview, and yeah, definitely interested to hear from others.
Thanks, Hunter.
Adriana has a question.
Oh, hi, Adriana.
Yeah, sorry, I can't see everybody's hands. So
Hello.
apologize for that.
Really, first, it's very nice presentation. Thank you. It's very clear what is the plan to do there. I would
Thank
like, please, to know more about Bell's Creek, because Bell's Creek is the water source for the Tierra del Mar. And I met Chris in the field. We briefly talking about that. But please tell me more. What are you planning to do there?
Yeah, well, as I mentioned, it's not being pushed forward as part of the 60% design, but we have been working on it. I don't have a great view of it to show, but essentially what's going on there. We have Belts Creek is one where the culvert is undersized and it also has a perched outfall, several feet of perch on that outfall. And I was actually surprised to see as we went upstream of Belts Creek that there are areas where the channel is quite wide. We were even getting active channel widths of 20 feet, more like 7 to 8 feet down where it's more channelized. But similar to Reneke Creek, it also is carrying a fair amount of sediment. And yeah, as you get, a couple 100 feet upstream of the roadway, it's pretty flat. It's very sinuous, and the floodplain is very activated. And so, all that said, what we're proposing there is actually a similarly sized bridge to Reneke Creek, probably in that 45-foot span range. And of course, you could put in, maybe a 18-foot box culvert or 20-foot box culvert, covered up with the road fill. The road is quite a bit higher, obviously, than the road over Reneke Creek. And so if working with Tillamook County Public Works about really preferring a bridge in that location, as we take the channel form and run that up to the roadway elevations, that ends up being about a 45-foot span once you get up to the roadway surface elevation. With that perched outfall, that does give us a little bit of elevation, grade change across that reach that we'll need to make up. And so there is, some length of channel restoration or kind of regrading within that area, but mostly limited to pretty close to the roadway itself. When you get upstream of Belts, as I mentioned, it's really nice condition, really great floodplain connectivity. And then shortly downstream from Belts Creek, it enters a pond. This is an area that was quarried out, and it's essentially a big bowl that Belts Creek flows into and kind of meanders through. And then there's a pretty big beaver dam drop as it re-enters more of a flowing stream channel. So the work that we would be proposing to do is limited to the roadway itself. No real change in roadway grade. Like I said, the road's already up quite high off of the channel, and so really no need to modify the roadway profile or elevation there. And then trying to keep the stream restoration portion pretty tight to the roadway, and yeah, certainly before it reaches the pond on the downstream side, returning it back to its existing channel.
No, really appreciate the explanation, because for us, for Forest Service, Bells Creek and Reneke Creek, they are important source of fish that they came there and they migrate to our Forest Service land to reproduce. And any change, any work that can be done there is greatly appreciated, because on the past I did surveys, principally in Reneke Creek, and we found a lot of fish there, principally steelhead and coho, a lot on the past. Yeah. And they are very important streams for us, for Forest Service.
Yeah, thank you. I just wanted. And you mentioned. Oh, go ahead, Krister.
I was going to say one really quick point. I know we're running out of time here, but I just thanks, Adriana. It was really interesting conversation that we've been having about belts, especially, and we're actually looking into this. I'm pursuing sort of getting out on the ground and getting the fish bios and Forest Service folks and some other people that have information about especially the intake structure there for Tierra del Mar, and taking a look at that and seeing if there's something that we can do down the road. Like Hunter said, and like I've said, that's not currently part of the funding package, but I think we have some pathways to pursue design for Belts and No Name and potentially Belts Creek water intake structure modification or something. We're looking into it for sure.
No, thank you so much.
Yeah, and you know, like I said, our look at Belts Creek right now is pretty tight to the road crossing itself, but definitely
Mhm.
interesting to hear about, you know, potential additional barrier upstream and just how the creek interacts with the Tierra del Mar water supply water intake structure. But yeah,
Yeah,
look
because at
forward
this
to
moment, the you mentioned before the Bells Creek culvert is perched, and this is the barrier just there at the road. And we don't have too much. Generally, we don't have fish there in Bells Creek now because that barrier. But on the past, the water source of Steelhead too. That creek. If you talk to Mr. Miller, Bob Miller, he can tell you about fish before the water source for Tierra del Mar. Yeah.
Yeah, we're trying to get out there with I'm gonna try and set up a site visit out there with him and other folks and hopefully you can join us, Adriana, and
Yes, I would love to.
we can take a look and see what's going on there and see if we can, you know, come up with something you know,
Yes.
as a
No, thank you.
Yeah, yeah. Other folks have questions here? We got about 5 minutes left, so I want to make sure if there are questions, we have time. I will say follow-up question. So to follow this meeting, I will share the recording will be made available to the public on the OPRD website, and I will share all the links and everything, and I will also share some notes and you know, transcript of the meeting after the fact. And I welcome comments and questions, and we can share those and try to answer those as a group collectively, you know, as we go forward here.
Yep, and then we're also gearing up for the next town hall meeting on October 3rd. So yeah, this today, you know, we've done these in pairs all along where we've hosted a tech team meeting and then a town hall meeting shortly thereafter, and doing that the same this time around. Just really an update on the 60% design, and yeah, glad to have everybody's participation. York, got a hand up.
Yeah, I had a question about the muted tide gate regulator. You mentioned the elevation that it was going to be set at. As part of this design, is there a management plan for that and criteria when it can be changed or altered, or what's the thought gone into that in the operational component of it?
Yeah, you know, a lot of muted tidal regulator systems keep water quite low. And so I'll just describe a little bit. You know, this is a slide from Nehala Marine Manufacturing and Leo Kuntz on conceptual operation of a muted tidal regulator system. So when the water's down, the float is down and the gate is open. And as water level rises, you know, this is obviously showing a farm back there, but that's often what they're used for. Um, the water level setting is driven by the upstream side. And so often these are set to allow water up to maybe like 4 or 5 feet, kind of mean tide level, before water starts to spill out onto the floodplain. And then when water does reach that set point, the float is triggered to allow the gates to close based on hydraulics. And then as the water level rises on the outside, the inside stays protected, and you know, water level doesn't rise anymore, except for when you have stream flows coming down the system. So with our system here, the system is actually set up a little bit higher than a lot of these MTRs typically are. And the beaver dam that's upstream is at an elevation of about 8 feet. And so we can really allow this gate to stay open almost all of the time. You know, from all the way up to 8 feet, which is high tide a lot of the times, and allowing that tide gate structure to really stay open almost 90% of the time. ODFW's fish passage criteria for tide gates and for the muted tidal regulator system is to have the gates open for at least 51% of the time. And with our system and the elevations, even of the channel, let alone the water surfaces that we have at Sitka Sedge, the gates will stay open most of the time, and then really only when they hit above that 8 feet, the gate will close. And so again, it'll be really limited times when this tide gate system's closed. It's really there to prevent the highest of tides from reaching Tierra del Mar. Also, yes, this system will have a water level management plan, but we would be proposing to just have one setting that it stays at all year long. Of course, these systems are adjustable, and they can be adjusted, and they can be used adaptively to, I guess adapt to water levels that you experience. So if for some reason with our 8-foot setting, we were seeing water get further back than we wanted to, or we wanted to keep it open for longer, it is physically adjustable, and then we would need to work with ODFW to approve adjustments to the water level management plan. So I don't know if that answers all of your questions or thoughts around that, but yeah, again, this is kind of a unique position for a muted tidal regulator compared to a lot of the other systems that are down lower that are really trying to prevent half of the tide cycle a lot of times. And so we have this opportunity where we're using the system to almost keep it open all of the time, but then close it just to prevent the highest of tides. And, we could set it a little bit higher, 9 feet, and that would start to overtop the beaver dam. And that starts to change our plan of, essentially keeping the beaver complex as is. It also would then start to fill up some of that basin of the south end of the marsh that will occupy storage capacity for stormwater. And so by keeping it at 8 feet, we're actually reserving all of the storage capacity for stormwater. And again, we're keeping the gates open for almost 90+% of the time.
Great. Thank you for the information.
Yeah, thank you. Great question.
Thanks, York. We're at 3 o'clock. So I want to, take up more time from folks' day than we said we were going to. So I guess we'll kind of leave it here. And like I said, I will share the recording, link to the recording and additional information. And I'm welcome comments and questions. And y'all have my contact and all of our contact information, I think. So I really appreciate everybody's time today. Sorry, we probably could have spent 2.5 hours talking about this if we really wanted to. And I think the town hall meeting, we will welcome the public and the community to voice their comments and sort of have a chance to share the project updates with everybody else at that point. And OPRD is going to kind of take the lead on the town hall coming up here in October. And so we will look forward to that.
Yeah, thanks very much, everybody. Appreciate
All right.
the time and input.
Thanks,
Thanks,
everyone.
everybody.
Thank you.
Thank you.
Thank you very
All right.
much.
Have a
Yep,
good
thank
day.
you. Bye-bye.
All right. All right.